Hi guys, we're about to get going on chapter 0. This is a intro to calc or pre-calc review chapter. We're not going to do the whole thing, but I wanted to start the year out with a few things to refresh our memories from last year and get started on a good track. This is section 0.2, functions and graphs. So all about functions. What we're going to learn this section is about domain and range. That's going to be a big part. We'll get into interval notation. We're going to talk about some good graph viewing skills. What does it mean to describe a function as odd or even? And then we're going to get into some interesting functions called piecewise. And then one you know pretty well called the absolute value function. You know composite functions pretty well. And why are we doing this? Well, functions and their graphs, particularly their graphs, form the basis for understanding a lot of mathematical applications. But in particular, if you don't understand functions and their graphs, you're going to have a tough time in calculus. So let's get going with a function. A function from set D for domain to a set R for range is a rule that assigns to every single element in the domain a unique element in the range. The set of all input values in D is called the domain of the function. The set of all output values in R is the range of the function. So we've got the pretty common graphic explainer of a function down below. Here we have a set of elements in the domain. They are mapped each to a set in the range. And notice that every element in the domain goes to an element in the range. Now, part B, this is not a function. Now, B is not a function because this element in D, the domain, is mapped not to one unique, but to two separate elements in the range. And that means we do not have a function here. The example I like to use is that two students can be in my first hour class at the same time, but one student cannot be in two separate first hour classes at the same time. Every single element from the domain goes to a unique element in the range. So function notation comes next. For function notation, in other words, how do we notate? How do we write that we're talking about a function? We use this, f of x to denote the range value that f assigns to the domain value x. The set of all points x, y in the coordinate plane determined by whatever the function's rule is, y equals f of x, is the graph of the function. So the set of all points in the coordinate plane is the graph. The variable x is the independent variable. The variable y is the dependent variable. So what do we mean when we start talking about the graph? Well, let's take a look here real quick. Maybe this is our function. This is the x-axis. This is the y-axis. This is the function y equals f of x, where the x's are the domain, and those are the independent variables, and the y's are the range, and those are the dependent variables. So, domains and range. Sometimes functions do not come along with an explicit domain, and in those cases, in fact, that's most of the time, we say the domain is implied to be the largest set of x values for which a formula gives real y values. For instance, if we looked at the function f of x equals x squared, well, we can plug in any number we want to there. So we would say the implied domain is all real numbers. However, if we look at a function such as f of x equals the square root of x, You cannot plug in all numbers there. So in this, negatives don't go in. You get unreal or imaginary values. So we would say here the implied domain is all numbers from 0 and greater. And then now and then, we're going to get a restricted domain or relevant domain where a function comes along with a domain. So we might say, oh, here's a function f of x is 1 over x for all x greater than 0. And so here the domain is implied, all x's greater than 0. And so that is a relevant or restricted domain when you are only asked to look at a certain part of a function. More on domains and ranges. The domain and range of many real valued functions of a real variable are intervals or combinations of intervals. The intervals may be open, closed, or half open, and they can be either finite or infinite. And so here we're really starting to talk about the bridge between graphically representing a function and notationally representing a function when we talk about the domains and ranges in terms of intervals. So intervals have boundaries. Think about the real number line and some things from Algebra 1 or even pre-algebra where you had to graph solutions to inequalities, and oftentimes you had to do maybe like a solid dot and an open dot and then shade in the middle. This is not much different than that. We're talking about the intervals in which a function is defined and then the range as well. And these can be closed, these can be open. If we talk about a number inside the interval, we're talking about the interior. If we're talking about some number on the outside, that's the exterior. So let's see what that looks like. Here's an interval. It is an open interval from A to B. So we can write this in either inequality notation or set or interval. I'm going to call this set interval notation. Right? So this represents all x's between A and B, but not including A or B. We see the open intervals there. Open interval does not include the endpoints. Right? And then here's a closed interval where we do include the endpoints, and notice the changes from parentheses to brackets. And notice the changes from less than signs to less than or equal to signs. And this has to do with whether we include the endpoints of the interval. We see on the next slide here that we can have intervals that are open on one end and closed on another. Or maybe open on the left and closed on the right. And we notice again that closed goes along with the bracket and open goes along with the parenthesis. Any number inside is referred to as an interior point of the interval. Here we have intervals that continue on forever in one or both directions. In this case, we use the infinity sign and the negative infinity sign. And we never put a bracket with infinity. Never use a bracket with infinity. We always use parentheses. All the way to the left is negative infinity. All the way to the right is positive infinity. And we can also begin and end intervals with an open number or closed endpoint, and those will be parentheses around or bracket in parentheses around.